How's it going, Online Math 121? This is the third video of the week, and in this one I'm going to tell you a little bit more about lines. On the final exam last semester, my students didn't do particularly well on the question that asked about parallel and perpendicular lines. So my hope is that this video will help you out with that this semester. Let's start with parallel lines. There's an example of a couple of parallel lines, and it's not too difficult to tell that these two lines have the same rise over run. They have the same slope. They have the same slantiness, to use a very mathematical term. So parallel lines have the same slope. Okay, that one's not too hard. Perpendicular lines are a little bit trickier. I'll draw just an example of two perpendicular lines. Perpendicular means they cross each other at 90-degree angles. And one thing that you can notice right away is that if you draw two perpendicular lines, one will always have a positive slope, and one will always have a negative slope. Of course, the exception to this is if we're talking about horizontal and vertical lines, but all other perpendicular lines, one will have a positive slope and the other will be a negative slope. Okay, well, what's the relationship between those two slopes, other than their negatives of each other? Well, just in this example, let's say that for every 2 units we go to the right, we go up 1 on that line. That would give us a rise of 1 and a run of 2, which would make our slope 1/2 on that line. Now you would expect this line to have kind of a similar thing going on. It looks like in this case, though, for every 2 units of rise you have, you get 1 unit of run on the line. And we already mentioned that the slope of this was negative. It happens to be -2 because the rise is -2 and the run is 1. While this is no means a mathematical proof or anything like that, it kind of gives you an idea of what the relationship between the slopes of two perpendicular lines might be. And that relationship is that perpendicular lines have negative reciprocal slopes. You'll notice that one is the negative of the other. And you'll also notice that if you took the reciprocal of either one of the slopes, you would get the other one. So just as another example real quick, if you had a line that had a slope of, say, 3/2, the slope of the perpendicular line, I'll just make up a little notation for that, the slope of the perpendicular line would be negative reciprocal. So -2/3 in this case. So there you go. If you have the slope of a line, and you want the slope of a line that's perpendicular to it, you just flip that slope over and put a negative sign on it. Okay, let's do an example. This problem is fairly similar to the problem that was on the common final last semester. We want to find the equation of the line that's parallel to this given line that passes through this given point. The key to starting this problem is realizing that by being given a line and saying we want a line that's parallel to that, that's giving us a slope. So the first thing we have to do is actually find what that slope is. And in order to find the slope for any line, we need to put that line into slope-intercept form, which means solve for y. So okay, we're going to get y by itself here. The first step to do that is to subtract x from both sides. Then I'm going to divide both sides by 2. And this -1x becomes -1/2x. And this +3 becomes +3/2. Okay, so we found the slope of the given line, and we're told that we want the equation of a line that's parallel to that. So all we need to do is say what's the slope of the given line, and that will equal the slope of the parallel line. So our slope is -1/2 in this case. So now we have the slope of the line we want, and we have a point. So we're down to a fairly simple problem. We could do this using slope-intercept form, or we could use point-slope form. I'll go with point-slope form again. Feel free to do what you like. There's our point-slope equation right there, and all we have to do is plug in our numbers. Our y value is 5. Our slope is -1/2. And our value for x1 is -4. We just need to do a little bit of simplification in algebra here and solve for y, and then we'll be finished. You'll recall that if you subtract the negative number, that just turns into a plus. In this step, I just distributed the -1/2 through the parentheses. -1/2 times 4 is, of course, -2. And in the last step, I just add 5 to both sides, and we have ourselves an answer. That is the equation of the line that was parallel to the given line that also happens to pass through the point -4, 5. There it is right there. Okay, one more quick problem. What would happen if we had the exact same problem, except the only difference was that we wanted a perpendicular line instead? So I'm going to steal some information from our last example. We found that the slope of the line that was given was -1/2. But this time, we want a slope of the line that is perpendicular to that. So what do? We take the negative reciprocal of this. That means to get rid of that negative sign and flip this thing over. So you get positive 2 as your slope. And I'll use that notation. This is the slope of our perpendicular line. Now we're going to finish this thing off the same way we did before. We have now a slope and a point. There's our point slope form again. I'm just going to do a little bit of plug and chug here. I plugged in my slope and I plugged in my point. Now I just need to simplify like last time. Again, a minus -4 is a plus 4. Again, I'm distributing the 2 through the parentheses. And again, I'm adding 5 to both sides to get my final answer. Okay, I hope that helps you out with parallel and perpendicular lines. I don't have anything else for you this week, but make sure to send me questions as you come across them, because your homework, show your work assignment, and your quiz are all going to be due very soon.